To finish up this section, let's state and prove a proposition. It says there can only be one perpendicular from a given point to a given line. So essentially that's saying if you have a line and a point, you can't have a perpendicular like this going through that point and a perpendicular like that going through the point. There is one and only one perpendicular to this line that passes through that point. So to prove that, suppose for the sake of contradiction, we're going to do a proof by contradiction. Suppose there are two perpendiculars from point A to a line M. I'm going to draw a small picture here. That's my line M. And suppose the point A is up here, and that we have two perpendiculars, this one and that one. Okay, call the perpendicular, perpendiculars, that's plural, AB, so put B, point B right here, and point C right here, where B and C are on the line M and they're not equal to each other. So angles ABC, that's a right angle, and so is ACB, because they're perpendicular to this line. Locate D on the side of BC, opposite A, so that means this side down here, opposite A, such that BA equals BD. So that means we have to continue this line. I'm going to kind of draw it like that. Call it line D. This is a line, and this length and that length are the same. And then what do we know from that? Since ABC is a right angle, so is CBD, or DBC. So this is also a right angle. All right, by side, angle, side, let me complete this right here. By side, angle, side, we can see that triangle ABC is congruent to something. Side angle is 90, side. Well, this side is the same as this one, same in length. DBC would be the other triangle. DBC. By side, angle, side. Side, angle, side. So by corresponding parts of congruent figures are congruent, we see that angle BCD is the same as the angle BCA, because they correspond in these two congruent triangles, BCD, BCA. So this angle and that angle. Oh, and therefore they're both right angles. Yeah, they're both right angles because we got perpendicular bisectors here. Okay. It follows that the line AD contains the point C. So C is in between A and D. Turns out, I know it doesn't look like it, but by the definitions, this is a line, just like this one is. So thus, to conclude this proof, we have B in between A and D, because this is a straight angle, so to speak. We have C between A and D as well, and they're not equal to each other. That is a contradiction. You can't have two distinct points between A and D if they are not equal to each other. Well, technically you can see ABD, ACD. Here they're not on the same line by the way we drew the picture, but they have to be. But since B and C are not equal to each other, we have a contradiction, as we have two distinct lines passing through A and D. That line is separate from this line because B and C are not equal to each other. This contradiction proves there can only be one perpendicular from a given point to a given line.